This is the November 2022 DBE NSC paper 2, question 7. Question 7 goes after using trig triangles. There's 2D and 3D shapes. Let's look at the information. So AB is a vertical flagpole. That is this length. So square root 5p meters long. AC, and AD are two cables. So those are cables from the flagpole to the ground. B, C, and D are in the same horizontal plane. So that just means that the shaded triangle is on the floor. So horizontal, it's on the floor. Okay. BD is 2p, so that's written on there in length, and ACD is x is given. AC, that's ACD is x. Oh, okay, it's in the front. It's in that front triangle. ACD, yes, ACD is x, and ADC is 45 degrees. ADC, so ADC, also in the front triangle. So this is a 3D shape. Has a triangle in the front. So there's basically four triangles altogether that we can work with. 7.1. Determine the length of AD in terms of P. So you're going to have AD on one side equal to something, something, something with P's in it. Okay. So we have AD on the left, and that's what AD in terms of P means. Let's take a look. So AD is on that front triangle, and it's also, so you see AD on triangle ADC, but it's also on triangle ABD. Those are our two options. If I look at the triangle ADC first, so that's the front one. And I noticed we have some information. If we have a 45-degree angle, we have an unknown angle, but we have no lengths. We have no lengths here. So I wouldn't be tempted to use that triangle to answer this question, because there's just not enough information to use there. So we look at the other triangle, ABD. We know that, that's a 90 degrees triangle, which really helps. AB, we can use any properties of 90 degrees triangles. When I see 90 degrees triangles, well, I think of SOHCAHTOA that we could possibly use because it's a 90 degrees triangle. And in addition to that, we don't have any angles. So we don't have any angles. So SOHCAHTOA, no, that won't work. What else is we do? 90 degrees triangle is Pythagoras. Anything with 90 degrees triangles. So it's asked for the distance. So yeah, Pythagoras will work on this particular problem. Oh, that didn't work. All right. So let's look at our actual working. Using Pythagoras, we know that AD is the hypotenuse. So AD squared is going to be, Pythagoras says that C squared, which is the hypotenuse, is A squared plus B squared. So that's the two shorter sides of the triangle. AD squared is going to be equal to 2p squared plus square root of 5p squared. So that's BD squared and AB squared. So AD squared is equal to 4p squared. Square root of 5 squared is just 5. and p squared is p squared. So 5p squared plus 4p squareds is 9p squareds. Last step, we don't want AD squared, we just want AD. So we take the square root of both sides. And the distance of AD is going to be square root of 9 is 3. And square root of p squared cancels out. It's just p. (7.2) show that the length of CD in the frontier is this whole thing. So we want CD, and it's going to be equal to something with sine, cos, and p's in it. So we know we don't have to give actual values. We can just leave it how it is, but it's going to have, we need some sort of sine, cos, and p is going to be part of the answer. All right. Let's take a look. So tools in the toolbox, we have the sine rule. If we look at the triangle that we just were working with in the previous question, we had a 90 degrees triangle. Wait, so this won't help because we need the full triangle. So we're actually using a non-90 degrees triangle. We want triangle ACD. That's the triangle. And we now have a distance. We have one distance. We have 3p, and we do have 45, and we have x. So this, we could either use the sine rule from the, which states that A over sine A is equal to B over sine B, and so on, where we're looking at a ABC triangle like this, and the small letter shows the side length. And the side length that we use is the one opposite the angle. So that's to do that one. Also for the cosine rule, you would do the same thing using this triangle for the cosine rule. Cosine rule, we have a squared equals b squared plus c squared minus 2bc, and cos of the angle opposite the side A, which would be angle A. So it uses that same technique. Okay, so let's look at what we have. Well, we have, I think I did just take a different color. So we have this angle X opposite the side 3P, and we have this angle 45 opposite some other unknown side length. And neither of those have CD in them. So what I would do is I would try and find one that has the unknown CD, and that would be this angle A. Currently, we don't know what the A is, but we do know that a triangle, the sum of angles inside a triangle equals 180. So we could say that angle A is equal to 180 minus x plus 45, the other two angles. So we can manufacture ourselves a angle A here. Okay. So I've just written in the information that we have there. So we're going to do, our unknown that we need is CD. So CD is opposite angle A. So we put CD using the sine rule. So we use CD over sine of 180 minus x plus 45. And this will be equal to, well, we choose another one that we have information on. And in this case, we have information on 3p from the previous question. So the side 3p over sine x. Okay, so now we can work with this. We just need to rearrange it and get CD on its own. So if we want to get CD on its own, we can times both sides by sine of 180 minus x plus 45. But let's take a look at quickly, well, let's first get that nicely done. So CD equals 3p over sine x times by sine of 180 minus x plus 45. Okay, this is a 180 plus minus. It can be reduced. And it's in the second quadrant. So the acute angle that is equal to this is just going to be x plus 45. We can, when we reduce this in, because sine is positive in the second quadrant. So where does that leave us? We have CD is equal to 3p over sine x times by sine of x plus 45 reduced over 1. At this stage, I always take a look at how the answer should look. And my answer doesn't look anything like that yet, but it's getting closer and closer. We've got the 3p there, but that's about it so far. So here I see a compound angle identity. Compound angle identity. Sine of A plus B, we have x plus 45. So here's a compound, the one we're using. So just make sure you copy it incorrectly. So CD is equal to 3p times by sine A would be sine x cos 45 plus cos x cos 45 cos x sine 45. And this is all divided by sine x times 1, which is just sine x. So whenever I see a 45 or a 30 or a 60, I think of special triangles. Because special triangles we can use to work that out. So we look at our special triangles, 45, 45 triangle. 45, 45, 90. It's got a square root 2 and 1s. So cos, if you look at SOHCAHTOA, cos is adjacent over hypotenuse, so it'll be 1 over square root 2. So CD is equal to 3p sine x. Cos of 45 is 1 over square root 2 plus cos x. And sine of 45 would be opposite over hypotenuse, which is going to also be 1 over square root 2. And all of this was over sine x in the denominator. Okay, I'm going to go back and look at what we were aiming for. So we are very, very close indeed. Got a square root 2 in the denominator. So, oh, the sin x was only over the 3p. Oopsie. See if that makes a difference. Okay, so this self-correcting these sorts of questions. So you get your answer, you can see where you went wrong. Of course, in the exam, there's no time for any mistakes. Got to be perfect. All right. Okay, so corrected this. This was more like this, sort of a timesing going on over there. That makes more sense. Okay, where were we? So we have 3p divided by sine x times by sine x over square root 2 plus, just to go over what the mistake I made there, it was because of this plus here. So you can't just, you need to be careful. It changes the, you'd have to find a lowest common denominator. There's more than one term. But it's all good now. So cos x, I hope. Cos x over square root 2. Doing a very long expanded answer here. So we need a lowest common denominator in order to add these terms at all. So our common denominator is going to be sine x times by square root 2. That takes into account everything that's there. This won't work. Keep, nope. It's more like this. This is together. Okay. So if I do this, what I self-corrected there just a minute ago was that if I do this, it won't look like the answer. So what I want is just one sine x in the denominator and the square root 2 on this side. So I'm going to find a lowest common denominator just of these two. And that's 3p over sine x is times by sine x plus cos x, because they have already a common denominator of square root 2. And now we can times top by top and bottom by bottom. And that gets us to where we needed to be, which was 3p sine x minus cos x. All over, let's just want to check it again. All over square root 2 sine x. Yes. And that's the end of question 7.2. Question 7.3, they give an actual value for P and an actual value for X, and they want the area of ADC. ADC, so that's this front area here. Okay. So first part is, well, we were given that P, we can work out what CD actually is now, because CD was equal to 3p sine x plus cos x. So now we could say it's 3 times 10 sine of 110 for our x plus cos of 110 all over the square root of 2 times by sine of 110. So this is an actual value that we have now. Just times the 3 by 10 and I got 30, but I'm going to leave this here because I want to avoid unwanted decimal points. So I'm just leaving this in exactly this form. I added the times there just for myself to see when I do add it into the calculator, I know that it was timesing. Okay, so this is just for calculate work. So we're looking at this front triangle and it wants the area. So we know it's a non-90 degrees triangle, and the area then is a half times A times B times sine of the angle C, where C is the angle sandwiched between the sides lengths A and B. So that's the area of a triangle that doesn't have a 90 degrees angle in it. So what we are using would be a half. Now we have CD, so we definitely want to use CD. We already have, this is CD here, okay. And we have 3P, which is AD. We have AD, and then if we look at that, our angle sandwiched between the two, let's pick a very striking color, yellow. So our angle sandwiched between those two sides is 45 degrees. Okay, just quickly clean up. So AD is currently 3P. So AD, we've been given a value for P. So AD is 30, which was 3 times 10. Okay. We sub the values we have into our area formula. So the area of triangle ACD is going to be equal to a half times by CD, which is 30 sine 110 plus cos 110 all over square root 2 times sine 110. So it's times by this, times by AD, which is 30, times by the sine 45 degrees. All of this goes in the calculator straight away. And we get the area rounded to 2 decimal points is 143. 0.11. Just that you go back and check, I think it was meters. Always go back and check your units. Meters, yes. So we're working in area, it's meters squared. That was 7.3. And that concludes question 7 of the 2022 November paper 2. Good.